This meeting is being recorded.
Welcome to the OCR computer science class. And we are on chapter number 1, computer systems. And the topic is von Neumann architecture. So basically, von Neumann architecture is a kind of a foundation for a concept of a proper computer or concept of proper computing. Almost all modern CPUs follow a similar design, formulated by the mathematician John von Neumann in 1945. So the question is, what is his idea that from 1945 till 2023, we are following him? So let me tell you what is the idea. Like, this is an input. This is a processor. I just write PR, okay? Or this is an output unit, right? Adam, are you there?
Yes,
You need to acknowledge me all the time.
sorry.
No problem. Okay, so this is a computer, right? Input, process, and output. So von Neumann proposed the idea that in our processing unit, we only process the data. We cannot store the data. So he proposed the idea of memory unit. So memory is the place where we store our data. So the memory unit is connected with the processor. This is von Neumann architecture picture, an idea, a concept.
Okay.
So the von Neumann design for a CPU includes 3 main elements. First, a control unit. Second, an ALU. And third, a small amount of memory called registers. So this is called the memory, right? Right here. So he gives the idea of register, right? So
Yes.
a CPU of von Neumann is look like this. This is a CPU, CPU. And in this CPU, von Neumann proposed an idea of a control unit. In CPU, we have a control unit that's called CU, an ALU, and
Yeah.
memory that's called registers. So I'm just writing REG. REG means registers, okay?
Registers. Yeah.
This is the idea of von Neumann. So till today, we are following the same CPU technology, right?
Yes.
Perfect. So this is a detailed picture of von Neumann architecture. So let's me discuss. So you can see a von Neumann architecture, CPU, right? I have drawn the same picture. Like I have drawn
Yes.
the control unit, I have drawn the ALU, and I have drawn the registers. But right now we have further types. Like in control unit, we have 2 things: clock and decoder. In ALU, we only do mathematical calculations: plus, minus, divide, multiply,
Yes.
that's greater than, lesser than, sorry, this one lesser than, this one is greater than. Okay, lesser than or equal to, greater than or equal to, and so on. So ALU perform these things. Registers, now the memory, this is the main idea. Like memory have different types, like MAR, memory address register, MDR, memory data register, accumulator, and program counter. These are
Okay.
basic von Neumann architecture model things. So what you need to do first, you need to take that picture first in your mobile phone.
I've drawn it basically, so
Oh, perfect. So listen, first you need to write down these clauses. Once you're done with it, then you need to draw it, okay? So take
Okay.
up your notebook, draw it, write it down first, and let me know once you're done.
This meeting is being recorded.
Okay, so now we are going to discuss about the von Neumann architecture in detail. And we started with the control unit first. So basically the purpose of the control unit is to execute instructions and send control signals to other components within a CPU. Like the name suggests control unit. So definitely this unit controls the activity, or it controls the flow of instructions in our CPU. So the control unit is a main part of our CPU, which always control the flow of data within the CPU, as well as it controls the other components like hardware or software, right?
yes.
The control unit contains two main components. So we have discussed it, clock and decoder. So what is the function of clock? The clock sends an electrical pulse at a fixed interval to synchronize activity between components within the CPU. Like you wanted to play a game in your computer. You click on a game application. It takes around 5 seconds to launch the game. How many seconds?
5.
5 seconds. So the clock is going to manage the application should open within a 5-second interval or in a 5 nanosecond interval. So if the clock is organizing the data in a particular time, our system works very well. If the clock failed to manage the data, or due to any reason the clock failed to launch an application or program in our computer, so our computer will be crash. Is it happening
Yes.
with you? Crash? कभी हुआ है computer?
Yeah.
कब होता है? कैसे होता है? कोई idea?
When there's too much information.
Yes. And sometimes what you're doing, you play the games, and due to some
Yes.
problem in the game, the memory will crash. So it happens with me thousands of times when I was a teenager and playing games. So my system becomes crash and my computer becomes restart because the clock is not able to manage. So of course the system will crash, right?
Yes.
So what is the work of decoder then? The decoder decodes instruction that are retrieved from memory during the fetch execute cycle. What do you mean by decode? Like,
Um.
let me tell you. Like if you input computer science, right? So the decode
Yes.
is going to decode my instructions like computer science. It translates computer science in this way. This is called decode. So the computer science word is decoded into binary. So this
Yes.
is the work of decoder, that it decodes or translates the input instructions or the instructions which are stored in memory and convert it, decode it into the binary one. In this process is called fetch execute cycle. So we will discuss fetch execute separately. But right now you need to understand the decode means to convert the data into the binary, the data which is stored in memory. Got it?
Yes.
So write down these points quick. Now the next unit is ALU. I think I have given you the concept of ALU. That ALU performs plus minus, divide, multiply, greater, lesser than, greater than, or whatever. Like comparisons and calculations, everything is there. So the ALU performs arithmetic, mathematical. Like these are called arithmetic, right? Hello.
Yes, sorry.
Okay, are you there? So
Yeah,
this
I
is
accidentally muted.
no problem. These are called the arithmetic one, as well as logical operations. So logical operations are greater, lesser, equal to, not equal to. These are called logical operations, right? So it's written all the things right here. As well as one more thing, Boolean logic operations are also performed by ALE. What are Boolean operations? Do you know?
And not, or
Yes. What is used for and?
and was
And is used for multiplication.
oh,
Or
I
is
thought
used
you were
for,
asking for the shapes
or is used for addition,
addition.
and not is used to invert the
Oh,
value, like change the
okay.
state. Like if you have a 1, so you will get 0. Okay, so all these results by the ALU are stored in a place called accumulator. Did you see this accumulator right here in the registers? Look,
Yes.
so all the ALU calculations are stored in accumulator.
Yeah.
Got it? Okay.
Yep.
Write it down quick.
This meeting is being recorded.
Now we are going to start the third category, or the third part of our von Neumann CPU architecture, and that is called
The
register.
register.
Yes. So what are registers? Registers are the temporary memory. You need to note it down with me. What are registers?
Okay.
I'm writing it.
Temporary memory.
Yes, are the temporary memory. Temporary memory. So they store our instructions for some time. Now you said, sir, RAM is also temporary memory. So RAM and registers both are same? No. RAM is a part of main memory, but registers are the part of the CPU. Did you get my point?
Yeah.
RAM and register both works in a different way. Although both are temporary, but both are different. So registers are the small area of a memory within the CPU. Each register is used to store a specific item of data. Like we have 1, 2, 3, 4. 4 types of registers. So every type of register works with some different thing. So the first two started now, like memory address register, MAR, holds the address and location in memory where data or an instruction is to be retrieved or stored. Do you understand what does it mean? MAR, memory address register.
It
Let-
holds the address and location
Yes.
for what memories need to be retrieved.
So this is your part of a memory compartment. Two compartments are there. One is called address, and the other called location. So let's suppose address of the location, like you have a proper address. Let me ask you the address. You said, sir, I live in UAE near Dera. This is your location. Dera is your location, but your address is any flat number, any Bangalore number. Like you said, I live in Bangalore number 5, ABC Road, London. So Bangalore number 5 and ABC Road is a particular address, and the London or any other location is a location. So that is how the MAR works. Memory address register. This registers work with the address and location of the data, right?
Yes.
Now MDR, memory data register, it holds the data or instruction that has been retrieved from memory. It's about to store in memory. Like MDR means data. Like I'm writing the data here. Listen, this is my data
Yes.
and this is my location, right? So this is the data. This data is stored in MDR. And this content, address and location will be stored in MAR.
AR.
So memory address location stores the address, memory data register stores the data or instruction, which is retrieved or stored in MAR. Did you
Yes.
understand it?
Yeah.
Yes, okay, write it down now. Perfect.
This meeting is being recorded.
Accumulator.
Yes, the other two registers are accumulator and
Program counter.
counter. So I already told you the accumulator. Accumulator works with the results of calculation. Like whatever you perform in ALU, the results will be stored in accumulator. Right?
Yeah.
Accumulator stores the results of calculation performed in ALU. Is that okay?
Yes.
Okay. Now program counter. Program counter holds the memory location address of the next instruction to be performed by the CPU. This is incremented one instruction has been retrieved in the fetch execute cycle. Now listen to me very carefully. This is a box. In this box, we have set of instructions, right? Like this is A, this is B, this is C. The program counter is going to count each instruction. Once the instruction is done, it will send to the fetch execute cycle. Then the next instruction B, the program counter works on B. Then it sends to the fetch execute cycle. And then the program counter works with the C. And then it proceeded to fetch execute cycle. So you can see every instruction is incremented by one. Increment means adding one instruction, like A is on 1, B is on 2, C is on 3. So the program counter is going to execute one instruction at a time. And the increment of 1 is going to be done. Like 1 is done, so it performed the second instruction. The second is done, so the program counter performed the third instruction. So did you get the concept of incremented one each instruction? Means adding one instruction into the next phase,
Yes. Makes sense.
right? So please note it down in your notebook.
This meeting is being recorded.
So we are calling fetch execute cycle word again and again, and definitely in your mind, you are thinking that what is fetch execute cycle? Like, what is the work of this cycle? So now let's discuss. The fetch execute cycle. An instruction is fetched from main memory, RAM or ROM, at the location held by the program counter register. Now listen to me very carefully. Don't write anything. Let's suppose I'm going to input an instruction, computer science. This is the instruction I have entered in a computer with the help of keyboard, right? So this instruction is entered into your CPU. Where? CPU. In CPU, it is fetched. Fetched means transported, sended into where? Into RAM or ROM. Into RAM or ROM, right? And from RAM, the program counter register will pick this instruction as an instruction number 1. I told you program counter is going to count the instruction. So it fetches this instruction from RAM or ROM and count as instruction number 1. So computer science is now in program counter as instruction number 1. Is that okay or not okay?
Yeah, that's okay.
Like I input computer science. My instruction is stored in RAM or ROM, but program counter fetch that computer science word from RAM or ROM and is stored as an instruction number 1. That's all right?
Okay. Yes.
Okay, now next. Number 2. The value of the program counter is incremented so that it points to the next instruction to be proceed. Now let's suppose I'm going to input another instruction. It is exciting. Like we are talking about computer science. So computer science is exciting. So this one is now entered again where? In CPU. In CPU it is stored in RAM or ROM. But from RAM or ROM, who is going to fetch? Program counter register. So this instruction will be stored as instruction number 2.
2.
It is exciting. It is exciting. So it means that program counter is incremented. Like it is moved from instruction number 1 to instruction number
2.
So the question, sir, where is instruction number 1? So instruction number 1 is fetched and it is decoded by the control unit. So instruction number 1 is now passes to the control unit, CU. And CU is going to decode it. What does it mean, decode? What does it mean? Like it is converted into zeros and ones.
Decode is to change the.
I told you already that it is converted into ones and zeros. That's what decoding. So what happened with instruction number 1? It is passed to control unit, and control unit decoded. Decode means convert the data in binary language.
Yes.
Any confusion?
No.
Okay, perfect. Now the 4th one. The CPU executes the instruction by performing an appropriate operation. For example, the ALU might perform a calculation or data might be loaded from memory. But is this any calculation work in these 2 instructions?
No.
No, of course not. Because computer science is a simple data which is now decoded in ones and zeros. So from control unit, the instructions will be passed. Now, the cycle repeats until a halt instruction is retrieved. So this cycle performs again until the halt means stop instruction is retrieved. Like the person is not going to input an instruction. So the cycle will be halted. Is that clear?
Yes.
Okay, please note down the points along with the diagram which I have drawn.
This meeting is being recorded.
So you can see how the fetch execute cycle works. First instruction is fetched and it is passed to the program counter. Program counter stores our instruction where? Into MAR. Where? Into MAR. MAR means memory address register. Now, once the PC is incremented to the next instruction, that will be needed when the cycle starts again. Like if you have done with the one instruction, the program counter passed our instruction into MAR and waited for the next instruction, right? The instruction is stored at the location held by the MAR is copied to MDR. Like the data which is stored in MAR, the address will be located with the help of MDR and it is copied into MDR. MDR stands for Memory Data Register. Then the instruction will be decoded. It converts into ones and zeros, and then it's sent to the outside of the CPU, like for the execution, like ones and zeros. This is our instruction. Now it is ready. So it is now sent to execute department. So the operation indicated by the instruction is performed by the appropriate component. For example, the ALU performs the operation, but ALU will not do anything because we have write computer science. So the value of the stored by the program counter or memory address register might be changed. So it means that if the instruction does not have any ALU work like plus, minus, divide, multiply, so our instruction will be executed and it converts back into computer science again in the original form. That is called encoding. Like our instruction converted from decoded to encoded version again in the back form, again back in the original form. Like we enter computer science. So on the monitor, after this whole process, we see the result computer science on the monitor because the instruction is being encoded and finally executed on the monitor.
Okay.
Like, look now, this is 1000. The computer understands what is written. It is written computer science. So now in execution, the computer is going to execute computer science on the monitor. So this will be the final result.
Yeah, okay.
Perfect. You just make it in your homework. Take the screenshot.
All right.
Okay. So understanding the operation program instruction, this is also in your homework. So I'm sending you the slides. Again, I'm sending you the slides. This one.
All right.
This one. Because you have the whole week. Our next class will be in the next week, no? Like on selected days. When is your Thursday? So you have the whole week to read the things and do the things. And if you have any problem, you can ask me in the class. Okay?
Okay.
Okay.